to jump to another topic, where diamond was formed. It is very well known from 1950s with about 30, 40 years of study. We know most of the diamond is formed in what we call the lithospheric mantle. That's about 150 to 200 kilometers. If you compare with the other materials human beings use to decorate our life, with turquoise, with pearls, diamond is a far more deeper formation than other materials. Actually, now we know some of the diamonds even come from deeper, from what we call the transition zone of the Earth and the low mantle of the Earth that span from about 200 kilometers up to about 800 kilometers. So this is a diagram just to give you the general information, and we're going to touch a little bit of details how we get to here. But for that, I have to touch a little bit about geology of the Earth. I hope you experience touch a little about this. The Earth's surface crust, we can see all types of rocks. But actually, we go to the deeper part of the Earth, the material composition are very simple. We have two types of the rocks. One is the prototype, that's the major material that formed out of the Earth, and the small one is the epigite. Think about the Earth is a big sphere. The radius is 6,371 kilometers. It's very big. When you go deeper, the pressure is going to increase dramatically. The temperature is going to increase. Any material, it will automatically adjust its format of existing with the pressure and the temperature, as you can see from ice, right? Water, vapors. It's just change with the temperature. Same thing for these rocks. How do we know this rock is going to change with the pressure? It has been a research for a long time by, of course, in the laboratory to put the rock into very high pressure and high temperature, and then to see how it changes. So I'm going to read a few minerals. I hope you can remember because I'm going to mention it. At the Earth's upper mantle, we have a lot of olivine. That's peridot, that's a gemstone. With the increasing pressure and temperature, it goes to wesleite, to remonite. I hope you remember this word. So remonite. Remonite occurs in Earth's transition zone, and it is formed meteoritic garnet. And if the pressure temperature goes further to the lower mantle, it will form ferripericlase. That's another name I want you to remember, ferripericlase and perovskite. So that's what the mineral was supposed to be in the very, very deep part of the Earth. In 1980s, scientists in Australia, they studied diamond and find something they cannot explain. They find a ferripericlase in diamond. So we just mentioned the ferripericlase only occurs in the very deep part of the Earth. So but we have only the high pressure experiment result that give us some hint. Some of the diamonds must come from a very deep part of the Earth. In 1990s, a group of scientists in Scotland, they studied diamond from Brazil, a mine called GIA, and they find they have perovskite and all the lower mantle mineral inclusions. These diamonds are very small, poor quality, industrial quality. One thing I want to explain a little bit about how important study of the deep diamond is. I want to talk about the concept of plate tectonics. We know the Earth outside is a crust, it's hard, it's about 30 kilometers thick. It is not one piece. Actually, the crust is many pieces. Together, they move around between each other, so they create the earthquake and the volcano eruption. What you see here, this red line, is what's called Atlantic mid-ridge. The new crust is forming there every day, every minute. Once the new crust is formed, the old crust had to go back to the Earth's internal. So this is plate tectonics, and it's very important to remember the Earth's crust material can go back to the Earth's internal, that brings water, that brings carbon back to the Earth's internal. That's extremely important for the diamond formation. Please, for the diamond formation, please keep in mind, tectonics, the plate tectonics is unique to the Earth. In other planets, at least in our solar system, there's no plate tectonics. Grant Pearson, the professor in Alberta University, he published a very famous paper about 12 years ago. He studied one diamond from Brazil. He found the mineral remonite, right? I mentioned it. It's from transition zone. Remonite is the major mineral of Earth's transition zone. There's more than 50% of the material of the transition zone are composed of remonite. The depth goes from 520 kilometers to 670 kilometers. Think about it, the volume is huge. And in this diamond, you find remonite inclusion, and remonite has have 1.4% of what is recycled from the ocean, transported to the Earth's internal. Since the volume is so big, we can do a simple calculation. In the Earth's transition zone, there are similar amounts of water as the ocean, as we see today at the Earth's surface. Now, Earth is the only planet in our solar system that has water at the surface that supports the life. It is only by studying diamond that we can tell that in the Earth's inside, we may have similar amounts of water stored there. So look at this diamond again. These are poor quality diamonds. And there's another group of diamonds that is so important for our industry. I just listed a few diamonds here. This is from graph about 300, one of the 300 carat. That's one of the biggest diamond, fancy diamond in the world. And the pink is about 60 carat. And I think that is a pink star. And the rough diamonds are over 1,000 carat from Botswana. And the other two, the pink and the blue, are over 10 carats. And the two diamonds in the right-hand side, one is very famous, right, from a royal collection, and then the whole diamond. The 5 stone at the left-hand side all claimed millions of dollars, and the 2 stone at the right-hand side, nobody can put a price tag on it. The formation of this diamond is just a mystery. Nobody knows how this big, commercially important diamond formed. The people who are interested in studying their formation will almost never have opportunity to access to these stones, like university professors. The owner will not put this diamond into the university laboratory. And the people who have access to this diamond, they don't really are so interested in studying how this diamond was formed in the Earth. It is GIA, we are in a very convenient position. We are interested in it, we have the knowledge, and we have the access to this diamond. So our study of this diamond started about 12 years ago from our postdoctoral program when Dr. Evan Smith joined us. He showed his interest in studying formation of this diamond. We soon recognized this very important big type 2A diamond, they are dramatically different from the rest of the other diamonds. He created this word called clipper. It's called clipper diamond. Now if you talk about diamond miners, they all care a lot about it if they have clipper diamonds because these are very high quality stones. For example, the Layton diamond, the diamonds from Layton mine. Clipper means calling them like inclusion poor, pure, irregular result diamonds. It's a group of special diamonds. And the Collingham diamond, of course, is, and actually the right-hand side is the second last diamond. It's the most widely studied exactly a year ago, last July. I flew to Botswana with my colleague and we studied the diamond. Now, let's look at what inclusions we have from this clipper diamond. They have a perovskite, by right, it's a perovskite, and they have a meteoritic garnet. This inclusion immediately told us these diamonds are from either transition zone or the lower mantle. And this is another famous diamond, they sort of promise, is magically turned into 223 deep flawless diamond. We in GIA, I probably tested every single of them, tested, but we tested the stones in New York lab. This diamond has a lot of black inclusions. They successfully get rid of inclusions and donated to GIA for research. That's so pre-samples for us to study what these black inclusions are that can tell us where it's formed. It turned out the black material, most of them are graphite, but at the center is a metallic inclusions. It is an iron, sulfur, and nickel. And we find a similar type of inclusions in many other big type 2A diamonds. So that means it's a big type 2A diamond that formed in the melt of a metallic melt. That explains how this diamond could grow so big. And the same inclusion from perovskite was discovered in type 2B diamond. That's similar to Hope diamond. That also demonstrated these are super-deep diamonds. So with that, we find out either this Clipper diamond or type 2B diamond, they are deep. They are super deep, from 300 kilometers to about 800 kilometers. This diagram summarizes our research result of a diamond formation. Most diamond, about 90–80% of the diamond formed in the lithospheric mantle of the Earth. That's about 50 to 200 kilometers. 2%, that extremely important, commercially important, big 2A diamond, big 2B diamond, they are actually formed in at this depth, about 600 to 800 kilometers. The subduction of the oceanic crust played a critical role to transport materials, water, carbon to this area to crystallize as a big diamond. Our research result, and basically Evan Smith's result, published in the top journal in our work in science, in nature, that makes us very proud ourselves as well. As you previously mentioned, we are research, we invested very heavily in our research. How does the deep diamond come to the Earth's surface? That's a question we need to answer. 800 kilometers is very deep. How does it come to the Earth's surface? So let's assume the diamond formed here. When during the subduction, the temperature of the Earth's crust was low, so the density was high. When they warm up in the Earth's internal, they get lighter. When they get light, they're going to go up. They will reach the bottom of the lithosphere, and then kimberlite is going to bring it to the Earth's surface. Kimberlite is a very special magma that erupts very, very explosively in very short period of time, bring diamond from this depth to the Earth's surface. If it is not quick enough, the diamond will all turn to graphite. So we're very lucky we have this special magma activities that can transport diamond to the Earth's surface. So with that, I want to say Indian people is a special group of people. I think that probably over 7 years they recognize diamond as something special. They worship diamonds, and it's time to transport it to Europe and become a very important part of the jewelry culture. And with all of us industries help now globally, diamond is used to, I would say, celebrate important moment of life, and from West to America to East, it's globally. We're in Singapore in the East part. I intentionally decided to show you this slide, this picture. This is a newspaper of a People's Daily in 1977. That's the key moment China started changing. This is the biggest diamond ever discovered in China, about 150 carat, I believe, and it remained to be the last one. Nobody knows the future about this diamond, but the discovery of this stone in 1977 is a national event. Because in 1976, the new generation of Chinese leadership just passed away. and the new generation show up. So discovery of this diamond is very symbolic. It's a national event and it's a national celebration.